He was tired of cleaning the board.
Trigonometry.
Can I just record?
Does this record your
Yep.
thing on there?
He's recording. He's gonna put it on YouTube.
Right triangles. Yeah, this thing's awesome.
And I wish we could do this. Why can't we have our iPads up?
I don't like it.
I mean,
Not sure why that's like that. All right. So, let's make sure we have all this stuff down. This is really about SOHCAHTOA. Okay. So, let's start with one of the basic ones that we're going to do. We'll do number 6 in the book. And this is what it looks like. There's a 90-degree angle. This is theta. And this side's 8. And this side's 15. Okay? So, at this point, what we want to do is go ahead and figure out all the different trigonometric functions. So, sine of theta, and the cosecant of theta, and the cosine of theta, and the secant of theta, and then the tangent of theta, and the cotangent of theta. So they all go together really well. And what's important for students to understand is it all depends on what corner you're using your trig functions for, okay? And you also need to understand legs versus hypotenuse. Hypotenuse is not a leg. Hypotenuses are connected to the 90-degree angle. What did I just say, hypotenuse? Legs. Legs are attached to the 90-degree angles. Okay, the hypotenuse is not. Okay, so this is a leg and that is a leg. Got it? So we do not know the hypotenuse. So the sine of theta, if we look at the sine, it is opposite and hypotenuse. All right, so, and again, it all depends on which corner you're reading it from. So since we're starting from theta, opposite over hypotenuse, opposite leg would be 15, hypotenuse, we don't know. Okay? So if we don't know it, sorry. So hypotenuse, we don't know. How do we figure it out? Pythagorean theorem, yeah. So a squared plus b squared is equal to c squared. A squared plus 15 squared is equal to c squared. Figure it out, please. You lazy people not doing anything.
I know it's 64 plus something.
Got calculators, let's go. Tell me what it is.
Wow. Hello. Do you have anything that you're going to trade for a pencil? What?
Trade, why?
We're doing something for French class and we need something bigger or better than a pencil.
My opinion is what is better?
Yes.
How about a big eraser?
I mean, that's what
pencil.
You'll give me the switch? I'll give you the switch just for this. Never mind. We're good.
Okay, fine. What do you get, guys? What's C?
What? I got 10.19. Oh, 1 point. I don't know. I got like. Is it 17? Do you want the controllers?
17 is C, guys.
You want it right.
All right, so H is 17. Got it? All right, now we can do the sine. So the sine of theta, again, is going to be the opposite leg over the hypotenuse. So that will be 15 over 17. All right, so what's cosecant then? Yeah, the opposite, 17 over 15. Cosine of theta. Cosine. Sorry, see if I can do this without screwing this up. So what's the cosine? Cosine is the adjacent leg, the attached leg over the hypotenuse. So 8 over 17. And then the secant is 17 over 8. How are we doing? Okay, good. Does that help?
Yeah.
All right, tangent. Let's go ahead and erase this. So tangent of theta is the opposite over adjacent. So opposite leg over the adjacent leg, 15 over 8. And then cotangent's 8 over 15. So we had to do a lot of things just to solve this whole triangle. Okay? All good? All right, let's move on to other things.
Is this all this is?
Huh?
Is this like all it is? Don't jinx
No.
it. Don't jinx it.
Sorry, too bad. All right, so now if I do this one, this is number 10. Okay, and here's what it looks like. So this is alpha, and this is Bravo. 5 and 3. Wow, that's just ugly. There's no theta. So now it wants to know, A, the sine of alpha, and then also the cosine of Bravo. Or beta, whatever. I don't know, whatever it is. Who cares? And B is the tangent of alpha and the cotangent of Bravo. C is the secant of alpha and the cosecant of Bravo. Okay, this is really simple. Pay attention. Sine of alpha. Which corner are we at? The lower left one. So from there, where is your opposite and hypotenuse? Opposite over hypotenuse, right? What's the hypotenuse? How do we figure it out? So 5 squared plus 3 squared is equal to the hypotenuse squared. Everybody do it? Don't use your calculator. You get to use your calculator plenty, okay? So 30. So it's the square root of 34, all right? So you got to figure out these things the best you can. Now we figure this out. The sine of alpha. Sine of alpha is going to be, again, the opposite over hypotenuse. 3 over the square root of 34. Except you can't leave it like that. You must rationalize your denominator. And then there you're done with that part.
Oh my gosh. I thought it was another. Yeah, the door's open.
Cosine is a reciprocal, right? Yeah. So it should be the square root of 34 over 3. Oh, I'm sorry. Sorry. No. Sorry. Hold on a second. We're at Bravo, right? So the cosine is the adjacent leg over the hypotenuse, which is 3 over the square root of 34. And what's that going to do? We're going to get the same thing, aren't we? Okay, so the whole point is these are equal at different corners. Okay? Sine and cosine are equal, not the inverse functions, not the sine and cosecant. So sine and cosine are equal at different corners. Okay? Same thing with tangent and cotangent. So tangent and cotangent are inverses of each other. So the tangent of alpha is going to be what? Opposite over adjacent, right? So 3/5. Cotangent at Bravo, cotangent is what? Cotangent is, instead of opposite over adjacent, it's adjacent over opposite. Still 3/5. Again, those two are the same at opposite corners, okay? Oops. All right, and then secant. What does secant go with? Cosine. So the reciprocal of the cosine at alpha. So the cosine is, what's cosine? SOHCAHTOA, guys. Adjacent over hypotenuse. 5 over the square root of 34. So 5 over the square root of 34. And then we got to rationalize that. And what's cosecant? What's cosecant go with, guys? Sine. So the reciprocal of the sine. Sine is opposite over hypotenuse. That's going to be, oh, I'm sorry, bravo. I did it wrong. Sorry. Bravo. The sine of bravo is opposite over hypotenuse, which is still 5 over the square root of 34. So again, those two go together at opposite angles. That's all that little section was to kind of show you. All right, but you'd have to remember which ones are paired. Okay? Which doesn't make any sense. It should be sine and cosecant, but it's not. So you don't have to remember that. But that was the point of that problem. Okay? All right, moving on up. And calculators. Let's make sure we can use calculators. Everybody grab their handy-dandy calculator and tell me what the tangent of 51 degrees is on your calculator. Take it out 5 decimal places, please. Tangent of 51. Which one's correct? Are we using degrees or are we using radians? Then your mode should be in degrees.
Is that 9?
Oops. There. Have to be in degree mode, 1.23490. All right, just kind of curious. Cosecant of 48 degrees. Now that we're in the right mode, make sure we are, yeah. How do you find the cosecant?
Hold on. Oh.
Isn't that what it is? Or just take the sine of 48 and hit the x to the minus 1 button. Okay? So that's just making sure you can use your calculator correctly. Everybody got it now? Excellent. Easy peasy. Okay, now let's go down and do some more calculations. Number 16. Here's the look in the book. There's your 90-degree angle. This is 4, this is x, and this is 30 degrees. This little pencil's awesome. Okay, so now you use everything you have been taught to figure out all the pieces. It says find the side label x. So we're not doing all the pieces here. That's in a minute. So all the pieces are just x. Look at the degree you've been given, the corner. Now you could do 60. You know that this is 60 over here. And you could always figure out the other angle. But use the angle they gave you. Okay? So we're finding x. 30 degrees is the corner we're looking at. So what have we been given as opposed to for SOHCAHTOA? Opposite, adjacent, hypotenuse. Which pieces, Brett, have we been given? We've been given the adjacent leg and the opposite leg. Which trig function do we use then? Guys, SOHCAHTOA. Tangent. Thank you. So the tangent of 30 degrees is equal to the opposite leg over the adjacent leg. Now, how do we solve? It's algebra at this point, okay? How do we get the x out? Multiply by x. Okay, so x tangent of 30 degrees is equal to 4. Now, how do I get rid of the tangent of 30 degrees? Divide by the tangent of 30. Now, you could actually use your calculator beforehand and get the decimal, or you can do it all at the last second. So take a calculator and do that quickly. Make sure you're in degree mode. 5 decimal places. Well, good?
Yeah.
Awesome. Good job. Moving on. So it all depends on which corner you're at, and that tells you which trig function you got to use. Okay? All right, let's keep going. Express x in terms of trigonometric ratios of theta. That's ugly. All right, so all you're doing there is it just means solve for x. Yeah. Anytime it says, hey, express this in terms of that, solve for the first thing they ask. That's what that means. So you have to set this up. So here's the problem. This is number 22. So we have a right triangle. We have x, y. It also says solve for y as well, but we'll just do the x one for this one. Here's theta. It gives it to you in that corner. So we're solving for x. Which pieces are we going to use? I want to know the pieces, the names of the pieces. So you're not going to use y as well. We only want one variable. So what pieces in conjunction with theta are we using? Opposite and adjacent, which is which trig function? Tangent. So the tangent of theta is equal to x over 4. How do I solve for x? Multiply by 4. And the answer is 4 tangent of theta. Done. So it's not telling you solve, it says express it in this terms. That's all that means. Okay? Next set. Sketch a triangle that has acute angle theta. Okay, let's sketch a right triangle. These are all right triangles. Otherwise, we have to deal with hinge theorem and stuff, and we're not going to do that yet. That's hard enough. Okay, so we have an acute triangle here. I don't know what happened with that. That was weird. Acute triangle. We'll say this is theta. It doesn't matter where you put it as long as you know which one's your adjacent and which one is your opposite leg. Okay? So we're going to do 26. And it says the tangent of theta is the square root of 3. Now you could remember that the square root of 3 is, the tangent of theta being the square root of 3 is the same thing as the square root of 3 over 2 over 1/2. Like I told you to remember. But you don't have to. You get the same answers either way. You could sit there and say, well, tangent is opposite over adjacent. Now you could put square root of 3 over 2 on the short leg there, or the long leg, and 1/2 on the short leg, and still get the same answers, okay? But you don't need to for this, because it's going to give you the exact same answer. So now it's wanting the other 5 trigonometric ratios. So sine of theta, cosecant of theta, cosine of theta, secant of theta, okay? And cotangent. First of all, what's the cotangent? Good students. Close. Square root of 3 over 3. Now, how do we get hypotenuse? Pythagorean theorem, that's right. Let's do that. 1 squared plus the square root of 3 squared is equal to h squared. Solve it, please. Out of time, so let me just go ahead and make it easy for you. All right, so 2. So now you can solve everything. Sine is what? Opposite. Square root of 3 over hypotenuse 2. Cosecant is a reciprocal. Good. Cosine. Secant. Now, last thing, real quickly, you need this. Number 30. Oops. Stop. I don't want anything.
Machine broke.
It won't let me, so whatever. Doesn't matter. Hey, this is number 30. There. 30. Come on. You're not going to get away from unit circle. What's the sine of 30 degrees? Sine of 30 degrees. 30 degrees. Sine is the short leg.
Oh my god.
Cosecant goes with what? Sine. So the reciprocal of the sine of 30 degrees is what?
2.
The answer is
2.
1. All right. Here. Okay. We ended yesterday with you guys pretty much through problem 44. Anybody need to see any of those?
You started 29, do
29? Another one of those?
Yeah.
Okay, so let's go ahead and do one like number 30, but we'll go, let's do, how about 34? Okay, so 34. 34 looks like this, sine of pi over 3 times cosine of pi over 4 minus the sine of pi over 4 and cosine pi over 3. Now there is a formula that goes with this stuff, but at the moment we're just doing it the long way. So what is the sine value at pi over 3? Pi over 3 is 60 degrees. What's the sine?
Yeah, I think it's
Okay, and the cosine of pi over 4?
divided by 2 over 2.
Okay, and that's a multiplication minus sine of pi over 4.
Divided by 2 over 2.
Good. Look at you guys all experts at that. Cosine of 60 degrees.
1/2.
And now you just do the math. So square root of 6 over 4 minus the square root of 2 over 4. So we're going to say that's the square root of 6 minus the square root of 2 all over 4. Good to go.
That's pretty easy.
That's the answer.
That's not too difficult.
I hope. That's the answer. Let's take a look.
That's all we had to do.
What number is this? 34? 4.
Could you make any
34, 6.2, right?
Yeah.
Did I do the right thing? 5 over 3. 5 over 4. Oh, I didn't see the square over there. Sorry, guys. Thank you. So this is supposed to be squared at the top. So once we get all of that, then you got to square it. Okay. So that means you got to square that binomial. So the square root of 6 minus the square root of 2 times the square root of 6. Oops.
Wait, wouldn't that just take the square root away from it?
No. Okay. So again, let's go ahead and do FOIL. Square root of 6 times the square root of 6, yes, is 6. But then you have a minus square root of 12 and a minus square root of 12, which would be minus 2 square root of 12. And then you need to break down the 12. And then also we need to do the last part. Plus the square root of 2 times the square root of 2 is 2.
Yeah, well. That's good.
So you got to break down that 12. Rewrite it. 6 minus, and you have this 2 times that 2, which is 4 square root of 3 plus 2. So now we have 8 minus 4 square root of 3. And again, this is all over 16. Yes, so now we're going to reduce everything by 4. And we get 2 minus square root of 3 over 4. And that's what's in the back of the book. They actually pull the 1/4 out in front and write it like this, but it's not necessary.
So leave it like the 2 radical minus radical 3 over 4.
Yeah. Okay. All right, now let's go on because I want to get to this other stuff that's in here. Again, you're to do the odds, so make sure you're what? Whatever the like. If it says, I don't think it's like this through this number, like specific numbers I have up there because there's a ton of them. If I say do 28, then do 27. Okay. All right. Let's do this one right here. How about 42? Number 42. Stop talking. There's your right angle. This is 72.3. And the angle is pi over 6. What do? It wants you to solve the right triangle, meaning everything. So first of all, what is this angle right here? What's pi over 6?
60 degrees. 30 degrees.
30 degrees. So what's that one?
60. Yeah, 60 degrees.
Good. So you solved that one. So now we need to get x and y. So use trig functions. So let's start with our 30 degree. That's one they gave us. Let's find x. So which trig function are we going to use?
30, 60, 90. No. From the x.
From pi over 6, we're finding x. That's the opposite leg. And you're given the adjacent leg. Opposite and adjacent, guys. Tangent. So we're going to do the tangent of 30 degrees equals x over 72.3. Everybody do that, please. Calculator. So multiply both sides by the 72.3, and x is equal to 1.3279, or I guess 1. Okay? So you solved x. How do we solve for y? Using the 30 degree corner.
Then you'd use another trig function.
Yes.
So you just
That's not right. No, I'm sorry. I didn't have the right numbers on here. 72.3 times tangent of 30. Sorry. 41. I thought those numbers looked a little small. This is 41.74242. Sorry. Nobody said anything. What's the matter with you guys?
we just figured you were right and we were wrong. Yeah.
Well, I corrected myself, so thank you. All right, now, pretend we don't have x. What pieces do you have? Starting from the 30 degree line, guys. Come on. What do you have? There's three choices. Right, we want to solve for y.
We've already used tangent, so we can mark that out.
Not necessarily, but okay. So what do we have? We have the adjacent leg to this angle, and we want the hypotenuse. Cosine is adjacent and hypotenuse. All right, so let's do cosine. 30 degrees equals the adjacent leg over the hypotenuse. Okay, so multiply both sides by y. And then we're going to divide off the cosine of 30. What's the matter?
I can't see that. Yellow.
The yellow? Okay, here.
No, I honestly can't see that. Well, no, I wonder why.
Can you see the blue?
Yeah.
Okay. So now we're going to... What?
Wayne doesn't know what color it was. He said blue. I can just see that. He said blue and his eyes were like, blue.
And so now we're going to divide off the cosine of 30. Can you see that?
Yeah, we're good there.
Okay. So now y is 72.3 divided by the cosine of 30.
I saw his head moving. I didn't see anything on the screen. I did too. I was like,
I guess that's a 5. All right, can we go on?
Yeah.
That's how you do those. You have to look and see what you have been given. There's 3 pieces. The corner and then the 2 sides of the triangle. And that tells you which trig function to use. All right, let's move on. Let's just do one of these. 48. $60. This is 85 on the side, and this is 30 degrees. And from here to here is x.
Hey, cheers.
Okay, so pay attention. What?
someone moved.
Sean, don't move your desk, and all of a sudden I get mine.
Lane goes, hey, Sharis.
All right, so we got to solve for x. This is a difficult problem.
Very.
Okay, so the first thing we want to do is probably solve for this whole side. Okay, we'll call this y. So what trig function are you going to use to get that side?
That's what I was gonna say.
Because from 30 degrees, we have the opposite leg over the adjacent leg, okay? So the tangent of 30 degrees is equal to 85 over y. Everybody solve for y, please.
Yes, I did.
Okay, that's y. And then we can also solve for this little area here. We'll call this z. How do I solve for z?
Oh.
Sure. So let's do that one. Tangent of 60 is equal to 85 over z. Everybody solve for z. All right, so how do I find x then?
You can take
Well, if you know that number, you can.
147 minus 49. Boom.
Yeah.
Yeah, you take the whole side, y, subtract z, and that should give you x, shouldn't it?
Yeah.
Yeah, subtraction, please.
Don't give the answer yet.
So I can't count it.
98.
Okay, good. That wasn't that bad. So here's the point behind these types of figures. You have to look and say, what can I solve for? You could have solved for the hypotenuse. Didn't need it. But you could have done it just in case that might be something that would be helpful. And keep going until you finally get to the point where you have as much things solved as possible. Once you've done that, then you need to understand what to do to get the last piece. All right? Good. All right, let's take a look. How about some story problems? Good? Ready? Any story problem you want to look at? Some of you that have been working on it? How about 54? Let's start with that until we get to the point that we have a question. You have one specific?
I said 54.
Okay. All right, so listen up. So plane is flying within sight of the Gateway Arch in St. Louis. So here you have a really awesome plane. Okay, and here is the Gateway Arch. And he's within sight of the plane, or excuse me, of the Gateway Arch. He's not flying at the same altitude, sorry. Let me redo that. Let's see, so we have the Gateway Arch here.
Oh. I need to move my airplane.
At an elevation of 35,000 feet, the pilot would like to estimate her distance from the Gateway Arch. She finds that the angle of depression to the point on the ground below the arch is 22 degrees. Oh, to the ground below the arch. All right, so let me redraw it. Okay, so from the plane to the ground at the Gateway Arch. There's your picture. Woohoo! Okay, so you're at 35,000 feet. Angle of depression. This is the angle of depression. Down from the horizontal. Okay. Not inside the triangle, but you could tell me what the angle is inside the triangle, couldn't you?
Yeah.
What is it?
68.
68, if you need it. You also could do this. Watch the screen. I could make this my right triangle and use that 22 degrees and say, this is still 35,000 feet over here. Okay, so you decide how you want to draw your triangle. Either one of those would have been fine. Okay? All right, so now, question A. What is the distance between the plane and the arch? And then B is, what is the distance between a point on the ground directly below the plane and the arch? So what they want is part A is that one, and this is part B here. Okay? So part A goes from the plane directly to the arch. That's your hypotenuse. And part B is if you were on the ground, how far away are you? All right, so having said that, I'm going to use the 68-degree triangle there. How do I solve for part A, the hypotenuse? Which trig function are we going to use? The adjacent leg and the hypotenuse is cosine. Very good. So the cosine of 68 degrees equals the adjacent leg over the hypotenuse. Solve it. Okay, 93,000 feet. Who got that right? Excellent. All right, how do we solve for B? So from 68 to get B, we have the opposite leg and the adjacent leg. So tangent. You should always keep using the same corner that we started with and not use the new numbers just in case you made a mistake. So like we could use the opposite, we could use the hypotenuse figure that we just figured out if we wanted to. You could use cosine to do adjacent over hypotenuse. But just in case you made a mistake, don't use those numbers unless you have to. Everybody understand what I'm saying?
Yes.
Okay. So we're going to use tangent. The opposite leg is B, and the adjacent leg is 35. And everybody solve that, please. How we doing? Every story problem is a little bit different, but if you haven't figured out yet, all you have to do is look at the corner you have and the two pieces you're looking for. Set up your proportion or your sides and your trigonometric functions and go from there. All right. Next question. Oh, let's see here. You just want me to keep going?
Yeah.
Showing you these? Yes or no? Or do you want me to shut up and so you can do your stuff?
Oh, you could do another one, please.
One more? Does anybody have one specific they want to see?
Haley, you got one specific you want to see? Usually the ones you can't do.
You want me to give you a hint of what you should do and then you can decide? I think we should do 60, but you tell me if
Let's
there
do
one.
60 then. I think we should do number 60. Haley, you like
Okay. All right, so here's the deal with 60, all right? It's going to take quite a bit here. So 60. Here's your picture.
Flag.
Yeah, this is the flag. Woo!
That's what I was going to say.
And this person's standing on a hill. Right here.
That's actually like really similar to the picture.
Okay, so this is 18 degrees, and this little piece here is